Plate tectonics and continental drift, shaping the world. Plate tectonics and continental drift, shaping the world. The Earth is a dynamic and ever-changing planet, constantly undergoing processes that shape its surface. One of the most significant drivers of these changes is plate tectonics, which includes the theory of continental drift. The concept of plate tectonics and continental drift has revolutionized our understanding of the Earth's geology and has played a pivotal role in molding the world as we know it today. The theory of plate tectonics suggests that the Earth's outer layer, known as the lithosphere, is divided into several large and small plates. These plates are constantly moving, albeit at an extremely slow pace, due to the convective forces within the Earth's mantle. The boundaries between these plates are known as plate boundaries and can be classified into three main types: convergent, diverge, and transform plate boundaries. Convergent boundaries occur when two plates collide. Depending on the type of crust involved, different geological features can be formed. When an oceanic plate collides with a continental plate, the denser oceanic plate is forced beneath the lighter continental plate in a process called subduction. This creates a subduction zone and can result in the formation of volcanic arcs, such as the Andes Mountains in South America. On the other hand, when two continental plates collide, neither plate can subduct due to their similar densities. Instead, the collision generates enormous pressures and forces the crust to buckle and fold, creating mountain ranges like the Himalayas. Divergent boundaries occur when two plates move apart from each other. This movement allows magma to rise from the mantle, creating new crust in the form of volcanic activity. The eruption of lava eats new land, often in the form of mid-oceanic ridges. These ridges can be found in various locations, such as the Mid-Atlantic Ridge, where new oceanic crust is continuously being formed as the American and Eurasian plates move away from each other. Divergent boundaries can also occur within a continent, which leads to the formation of rift valleys. The East African Rift Valley is a prime example of this, where the African continent is slowly splitting apart. Transform boundaries occur when two plates slide past each other horizontally. These boundaries are characterized by significant amounts of seismic activity, as the plates continuously grind against each other. The San Andreas Fault in California is one such example of a transform boundary. While no new crust is formed at these boundaries, the continuous movement can result in earthquakes and reshaping of the Earth's surface. The theory of continental drift, proposed by Alfred Wegener in the early 20th century, provided the foundation for our modern understanding of plate tectonics. Wegener suggested that the Earth's continents were once joined together in a supercontinent called Pangaea, which began to break apart around 200 million years ago. He used evidence such as the fit of the continents, similar rock formatio, and matching fossil records to support his theory. However, it was not until the advent of modern technology that the theory gained widespread acceptance. One of the critical pieces of evidence supporting continental drift is the presence of matching rock formations and ancient fossils across continents. For example, similar rock units in South America and Africa, such as the distinctive red sandstone of the Karoo supergroup, provide compelling evidence for the continents being connected. Further support for continental drift comes from the study of paleomagnetism. Over time, the Earth's magnetic field has reversed several times, leaving behind a record in the form of magnetized rocks. By examining the magnetism preserved in rocks, scientists can determine the latitude at which they were formed. Comparing this information with the current locations of these rocks provides evidence of continental drift. The implications of plate tectonics and continental drift extend far beyond the realm of geology. These processes have had a profound impact on the evolution of life on Earth. For example, the movement of continents has influenced climate patterns and the distribution of various plant and animal species. It has also played a role in the formation of mountain ranges, which in turn affects weather patterns and the availability of resources such as water and minerals. Furthermore, plate tectonics plays a crucial role in the occurrence of natural disasters. Subduction zones, where one plate is forced beneath another, are known to produce powerful earthquakes and tsunamis. The devastating 2004 Indian Ocean tsunami and the 2011 Tohoku tsunami in Japan are tragic examples of the destructive power unleashed when these boundaries rupture. Plate tectonics and continental drift have had a significant impact on shaping the Earth's surface and geological features. The theory of plate tectonics suggests that the lithosphere is divided into several plates, which constantly move due to convective forces in the mantle. These plates interact at plate boundaries, including convergent, divergent, and transform boundaries. Convergent boundaries occur when plates collide. Oceanic plates subduct beneath continental plates, leading to the formation of volcanic arcs. When two continental plates collide, the crust folds and buckles, creating mountain ranges. Divergent boundaries occur when plates move apart, allowing magma to create new crust through volcanic activity. Mid-oceanic ridges and rift valleys can form as a result. Transform boundaries occur when plates slide horizontally against each other, causing seismic activity and reshaping the Earth's surface. The theory of continental drift, proposed by Alfred Wegener, suggested that the continents were once connected in a supercontinent called Pangaea. Evidence such as matching rock formations and fossils supported this theory. Paleomagnetism, the study of magnetized rocks, further supported continental drift by revealing the changing magnetic field and the movement of continents over time. Plate tectonics and continental drift have implications beyond geology. They have influenced climate patterns, the distribution of plant and animal species, and the formation of mountain ranges. Processes also play a role in natural disasters such as earthquakes and tsunamis. Plate tectonics and continental drift have fundamentally shaped the Earth's geology and continue to impact the world as we know it. The theory of plate tectonics explains the movement of the Earth's lithosphere, which is composed of numerous plates. These plates are in constant motion due to convection currents within the mantle. Convergent boundaries are formed when two plates collide. If an oceanic plate and a continental plate converge, the denser oceanic plate is forced beneath the lighter continental plate through subduction. Tie-in. This can create volcanic arcs and mountain ranges. When two continental plates collide, neither can subduct and instead, they crumple and fold, forming massive mountain ranges. Divergent boundaries occur when two plates move away from each other. This movement allows magma to rise from the mantle, creating new crust. Volcanic activity forms mid-oceanic ridges, where new oceanic crust is continuously generated. Divergent boundaries can also occur within a continent, leading to the formation of rift valleys as the landmass splits apart. Transform boundaries are characterized by plates sliding past each other horizontally. Although no new crust is created, the friction between the plates results in frequent seismic activity. The San Andreas Fault in California is a famous example of a transform boundary. The theory of continental drift, proposed by Alfred Wegener, posited that the continents were once joined together in Pangaea and have since drifted apart. Supporting evidence includes the fit of the continents' coastlines, matching rock formations, and similar fossils found across continents. Paleomagnetism, the study of Earth's ancient magnetic field preserved in rocks, further supports continental drift. The effects of plate tectonics and continental drift extend beyond geology. The movement of continents has influenced climate patterns, the distribution of species, and the formation of mountain range. Climate patterns are altered due to the changing geography, affecting temperature and precipitation. Different species evolved separately on isolated continents, leading to a variety of unique ecosystems. Mountain ranges impact weather patterns by creating barriers for air masses, and their erosion exposes valuable minerals and water resources. Natural disasters are also influenced by plate tectonics. Subduction zones, where one plate is forced beneath another, can trigger powerful earthquakes and tsunamis. The devastating disasters in the Indian Ocean in 2004 and Japan in 2011 are tragic examples of the destructive power released when these boundaries rupture. The theory of plate tectonics and continental drift has revolutionized our understanding of the Earth's geology and has played a pivotal role in molding the world as we know it today. Plate tectonics suggests that the Earth's lithosphere is divided into several large and small plates that constantly move due to convection currents in the mantle. These movements occur at plate boundaries, which can be classified into three main types: convergent, divergent, and transform plate boundaries.